Hello team, today's challenge is matrix shift, where we are given a matrix along with a shift number, and we have to move it left or right. We have to move the contents of the matrix left or right. In this case, if it's positive, they are moving right, so 1 becomes 2, 2 to 3, 3 to 4, and 6 being on the end wraps all the way around to the beginning, so it ends up looking like this with 6 at the start, everything else in place. If it was -1, it would go backwards. So 6 to 5, 5 to 4, all the way through. 1 being here, skips out and comes all the way down and becomes the last item, okay? And so on, etc. down the line, including this -54, which we'll have to take care of because there are only 16 elements in this array, in this matrix, right? So we'll have to do some tricky math to get there. Not complicated, though. So over to the code, we are going to start off with some stuff, okay? And what we're going to do is we are going to grab the chunk length, okay? Chunk length is going to be matrix 0, just like this, dot length, okay? So we're getting that first row, we're getting the length. My assumption here is that because we're calling it a matrix, it's a rectangular shape. So all rows are the same length. And of course, you have the length of the rows themselves, how many rows there are. Okay, if it's different, you can certainly do that, right? You'll just have to do something else other than chunk length. You have to do a little bit of extra looping to get that done, but certainly doable. Okay, for now, we're calling it a matrix. We're going to assume that it's rectangular in shape, which means that this gets it done. Okay. The second bit is something that I'm calling flat matrix, okay? And that should tell the story where we go matrix flat, okay? We don't need any arguments for this because we're only reducing it one level. We only care about one level. If you were doing something else, you can enter any sort of number in here, including capital I infinity, and it will reduce it that number of embeds, right? So it'll flatten it that number of times, okay? Again, we don't need that, so I'm going to empty that out. And here is our first real thing. So flat matrix will give us an array, okay? We're going to set that to new array before I get my naming wrong. And we're going to create array shift. Sorry, no dot involved, okay? Array shift is going to take flat matrix, okay? Because that's our array. And it's going to take our shift times -1. Why -1? Okay, why -1? Well, if we're over here and we take a look at this, okay, this is a 1. So if we go 1 times -1 is -1, and we go from the end right here, if we slice off -1 and then move it to the front, that will give us the same thing, 6, 1, 2, 3, 4, 5. Okay, if it is -1 and we go -1 times -1 is +1, right? So we slice off just this one, or sorry, we slice off everything except this one because of how slice works, and move that to the front. Now we get 2, 3, 4, 5, 6, 1, okay, which is the second example here, right? And so on down the line. So 5 times -1, -5, we go 1, 2, 3, 4, 5 from the back end. So 5, we slice off everything from 5 to the end, and move it to the front, 5, 6, 7, 8, 9, 1, 2, 3, 4. So it works, right? And it works quite brilliantly. Now, I'm putting it here because all the functions that come after shouldn't really care about that kind of math, right? That is very high-level math doing this conversion. All they should care about is taking whatever this number is and returning an array based on that, okay? And interestingly enough, because we're here, if you have done the challenge, it's called Array Shift from November 13th, 2025. If you've done that one, you can use that code right now. Okay, so I'm going to do exactly that. This was my solution, or very similar to my solution. I have changed it a little bit, right? But we create a function, Array Shift, and this is going to be the array, and this is going to be the shift, because we no longer need this times, and we are going to pass that in, okay? What are we going to pass in? Well, the first thing that we're going to do is get an adjustment, okay? That adjustment is, it depends on whether we're starting at the front of the array or the end of the array, at the start or at the end of the array, okay? So we need to figure that out, and we're going to call this the real shift because that seems useful. And that's going to be get real shift. In my original solution, I did not do this specific function. I had it all inside of this array shift function. So again, small changes, right? I've learned things along the way too. So get real shift, we're going to pass in the shift and the array dot length, just like this. Excellent. With real shift, before we go and create that function, we are going to return an array, okay? And that array is going to be spreading in array.length, array.slice, okay? And it's going to be real shift, okay? And then of course, that's everything from whatever this number is to the end. So we need to get the beginning, which is going to be from 0 to, but not including whatever this real shift number is, okay? And this is how we get this shifted array, okay, which we will fix down here in a few seconds. But get real shift, we haven't done that, so let's go and do that. Function, passing that in, we have the shift. Let's get rid of this because that's not useful. So our arguments are shift and length, and we do stuff here. The first thing that we need to do is const real shift again, okay? Apparently I'm not very original with my names, but that's okay, okay? So that real shift is the shift modulo length, okay? And this line right here is how we get around this big minus 54, okay? We divide the number of items inside of the array, inside of the flattened array. We divide this number by the number of items in this array. And that gives us the remainder, which is the same, okay? We could loop through this 54 times, or we could loop through this, the remainder of 54 divided by 16, okay? So options, right? Depending on what you want to do. I do not want to loop through 54 times, so I'm going to simplify the math by doing this, okay? Right here, we return, okay? What do we return? Well, we return math.sign of real shift, okay? Whoops, put it in brackets so that we're doing it right. Real shift, okay? In fact, I'm going to use that a couple times. If that is equal to -1, math.sign returns -1, 0, or 1 for +1, okay? It can also at times return -0, but I haven't seen that here, so I think we're okay. And we're only testing for -1 anyway, so pretty safe, okay? But if it is minus, we do one thing. If it is not minus, if it's positive, we do another, which is return real shift. It's the positive version, which means that we are working from the start and counting forward. If it is not, then it is going to be the length, double checking my math, yeah, length plus real shift. Plus might throw you off here, right? Remember that it is a negative number. If it's on this line, it's a negative number, which means that anything plus a negative something is the same as anything minus the absolute version of that something, okay? So plus minus something is the same as minus that something, okay? So that's how that works. We can make that work, which means that now we have our shift, which we're getting here, which we're using to slice, which means that we're getting that array and everything is working well. All we need to do is chunk it back to its original matrix form, okay? And we do that right here. Now what I'm going to do here is I'm going to pass in a function called chunk, okay? And that function is going to have the array, new array, just like this, and our count, which is chunk length, okay? Just like this. This is something that we have not created. So way up here, we create this one special. You might notice that I spread this out. That's very important for what we're about to do, okay? We'll come back to that in a second. So right here we go function, and a lot of people put the asterisk on the end. We'll talk about that in a second. And then chunk, okay? We pass in our array, our count. We can set a default to the count. I like doing that. and we do stuff. Now, the asterisk turns this into a generator. Okay, it's a generator function, which means we don't really return from it. You can use a return statement in here, but generally speaking, we yield. Okay, so just like this, every time we hit a yield, it pauses the function. Okay, so long as there's still stuff that we can return from this function, it will pause the function and hold it in memory so that we can call it again, or call a thing on it called next, and it will yield the next thing and the next thing and the next thing. Now, there's nothing in about this that will allow us to do that loop. We actually need a loop, and for that we usually do while. Okay, so array.length, if it is greater than 0, then now we yield. What do we yield? Well, we yield array.slice count. Oh, sorry, 0 to count. Okay, so we're starting at the beginning and just taking 3 items. Okay, with slice, remember that this is an index, so it takes everything from 0 to, but not including that index. Okay, at which point it pauses and waits for you to call it again. And if you call it again, then it will do the next step, which is array equals array.slice count, right? That's what I need. Okay. So again, with generator functions, they kind of loop internally, or they set up for iteration, which means that it will yield, it will pause here, and then when we call next on chunk, it will go, okay, I'm going to do this step, and then I'm going to go back to the start of the loop, and I'm going to go here on, oh, it's another yield, so I'm going to return this and pause. Okay, and it does that until it runs out of stuff, at which point it ends. Okay, that's where it yields, saying that there is no more stuff. Okay, very interesting stuff there, very cool to work with, but now we can use that down here, and that's exactly what we've done. We've spread it out, and the spread operator, coincidentally, is a form of iterator. So it will loop through, right? It'll loop through the chunk generator function until it runs out, and then that will be the final array, which means that it works. Okay, that was a lot. Okay, like starting at the beginning, we took our matrix and we grabbed some information from it that we used at the end, right? So starting clean, ending clean. Then we flattened it out to make our lives easier. Okay, because it's easier to shift and adjust a flat array of data. Okay. From there, we did exactly that, where we popped up here and got the actual shift, right? So we did a little bit of math. If it was minus, we did one thing. If it was plus, we did another. And we used that information to reorder our array. Brilliant. And then to finish, we used a generator function to help us with chunking this back into useful data, right? That was a lot, right? It was. And again, the middle part, this right here, if you did that other challenge, that array shift challenge, you could have used your code right here instead of mine. Or maybe your code was exactly like mine, which is also cool, okay? But for today, this is it. Did you find anything interesting? Did you find anything you hate? Is this the first time that you've worked with generators, right? Could be. Could be a very powerful tool in your toolbox for the future. But yeah, hit me up in those comments. Let me know what you think of all of this. And I will see you in the next one.